Well, hello and welcome. This is Laura Brandenburg from Bridging the Gap. And today we're going to talk about how to get started with data modeling. And after completing this lesson, you will understand the role of data modeling in the business analysis lifecycle and when to use specific data modeling techniques. You'll also choose a domain or a project to practice the data modeling techniques, and this will apply no matter what your current job role is. So first, let's talk about what data modeling is, and I'm going to walk you through a scenario here. So imagine yourself going up to the checkout counter of your local convenience store. You have 5 items in your cart that you put one by one onto the conveyor belt. The clerk scans each item into the checkout system. The checkout system tallies your total amount due. You pay for your items and are given a printed receipt. Behind this everyday process is an incredible amount of data. First, each item you purchase has a record in the checkout system that identifies its price. The price is most likely linked to a unique identifier for the product and was provided by a product management system. Second, your collection of purchases gets tallied together as an order, which includes a set of items and a total amount due. Third, once you pay for your item, the system might store transaction information, such as the payment method, and in the case of a credit card payment, a transaction ID provided by a merchant account to validate that the necessary funds are available. Come to think of it, your credit card also has a record that is stored in a variety of different systems with associated information such as your cardholder name and available credit information. Once the transaction is complete, the checkout system may send a message to the inventory management system so that the store's purchasing agent can keep tabs on when to order more of the items that will soon be out of stock. And we haven't even dealt with coupons, refunds, sale prices, multiple instances of the same item, sales commissions, customer loyalty cards that identify you with your purchase, or information known about the clerk processing your order. Information or data lies behind every business process and every software system. When, as business analysts, we specify requirements for new systems, we will nearly always touch the data. When we model, clarify, update, and improve business processes, we need to understand the data that business users receive, input, and report out on. And looking at the domain from a data perspective helps us ensure that we don't overlook critical requirements. So data modeling is a set of techniques and models that are used to define and analyze data requirements to ensure the data managed by information systems supports the business processes executed by stakeholders and the functional processes or requirements executed by software applications. You do not have to be a technical person to understand data or to complete basic data modeling tasks. You do not need to be able to write SQL queries, model physical databases, or create data storage systems. You do have to be logical, analytical, and be able to understand the role data plays in a process to be able to model that data effectively. And these are all traits of a good business analyst. What's more, it's incredibly important for business analysts to be involved in data modeling and not relegate this task to the software development team or the database administrator. I've seen that happen way too many times. There are extremely important business decisions that get made when it comes to how to create a database. And it's best that those decisions get made with business input and not by a default set of assumptions a database developer might make. With your strong business relationships, understanding of the business and functional processes, and analytical thinking skills, you as the business analyst are in the ideal position to help business stakeholders make decisions that impact how information will be managed in data management systems, often for years and sometimes decades to come. Here are a few scenarios where lack of business involvement in the data decisions could have led to missed requirements cropping up late in the project cycle. Late in testing, we learn that there isn't just one price, but there is a manufacturer's suggested retail price and the store's current price. A new field needs to be created, a new user interface screen with business logic needs to be created to update this field, and several software functions need to be updated to use the new field instead of the original single price field. Another example. After finalizing the database design, we learned that the database developer's decision to assign each item a unique identifier within the local store management system conflicts with industry standards, which base everything around a centrally managed identifier. The design needs to be updated to accommodate this new identifier and use it as a primary key for several tables. Finally, during user acceptance testing, we learned that each order must be associated with a customer service clerk so that we can report on productivity metrics. Although a relatively simple change, famous last words, updating the database and checkout functionality delays the implementation of the project. A mature business analyst like you combines business process modeling, functional requirements modeling, and data modeling to look at a set of requirements from all possible angles and ensure no requirements get missed during the elicitation process. Data modeling techniques are one type of requirements model that will help you ensure your requirements are clear and complete, and that business stakeholders are making the important decisions about how information technology systems are designed to meet their needs. Specifically, data modeling techniques are going to help you ensure the database structure of information systems will support the business information needs, and that data gets transferred between two or more systems in a way that will make sense to business users. Blip. Now, as a business analyst, you'll focus, delete that past. Now, as a business analyst, you can data model, even without a technical background. And that's because as a business analyst, you'll focus on conceptual and logical data modeling. The kind of modeling and analysis that will help you clarify requirements related to managing information, not enabling you to build the actual database storage system that actually creates, updates, and otherwise manages that information. You want to empower yourself to go as deep as understanding what fields are in the data storage system and how to define what kind of information they need to hold. And the data modeling techniques that we cover in this course will help you identify and model the following types of requirements. How to learn a new business domain more quickly by identifying key business concepts and how they relate, such as whether every system in the organization has the same concept of quote-unquote order or quote-unquote customer. Seemingly simple, but often misused terms. How to model the flow of data between systems so you can understand the potential impact to functional and business requirements, such as how the checkout system validates payment information with a credit card processor, just as an example. You'll go as deep as how to communicate specific details about the information, such that that item can have one and only one price, and that the price needs to be numeric. You'll go as deep as how to specify the source of information, such as whether the price is stored and managed internally or comes from an external data source. And finally, you'll go as deep as how to specify translation rules when data does move between systems, such as although pricing information comes from an external source, say in UK pounds, it needs to be translated to US dollars, and that the currency translation process needs to meet specific requirements, all important things to the business, right? Now, as a business analyst, though, you typically do not need to create those translation tables. Build the logic that transforms the data. or load the data into the database. Those are database developer responsibilities, not business analysis responsibilities. But you do need to give the database developer a well-organized collection of information that gives them the information they need to build the databases the right way, and by taking these really important stakeholder needs into account. And also to make sure that the business stakeholders are making appropriate decisions about how to organize their data. In my experience, it's this work, which often happens before the requirements or even alongside the requirements, that helps teams avoid truly icky, tricky project challenges that otherwise surface later in the project. Because if you wait until you build the database or even start managing data in that database to discover that the technical design doesn't support the business needs, you end up with a lot of rework and some very, very frustrated people. Now that we understand, hopefully, what data modeling is at a high level and why it's important, this is important, why it's important for you as a business analyst to get involved in data modeling and not just leave this to somebody else to figure out. Let's take a quick look at the data modeling techniques that are commonly used by business analysts and when they would typically be used. So we'll talk about the glossary, the entity relationship diagram, the data dictionary, the data map, and the system context diagram. Okay, so first there's a glossary. And a glossary is a deliverable that documents terms that are unique to the business or technical domain. A glossary is used to ensure that all stakeholders, both business and technical, understand what is meant by the terminology, acronyms, and phrases used inside an organization. A glossary is nearly always relevant whether you create it as a separate document or incorporate terms and definitions into your other deliverables. In fact, I bet a lot of you as business analysts use a glossary, but you've never really thought of it as a data modeling technique. It is where data modeling starts because this is where you get the common language. And if you don't have that common language when you start a project and start data modeling, you are going to experience a lot of challenges when you do start modeling the data, as you won't know how to communicate clearly about your business concepts. What's more, by honing your skills at identifying terms and their definitions, you'll be able to learn a new domain more quickly, clarify communication between stakeholders, and write clearer requirements. As an experiment, I challenge you to ask 3 stakeholders how they would define the term customer and compare the results. Then facilitate a discussion to create a shared definition of the term customer and document the result in a glossary. Next, let's talk about the entity relationship diagram, or ERD. An entity relationship diagram is a data model describing or visualizing how entities or concepts or things relate to one another. When created by business analysts, ERDs can be used to understand the business domain, clarify business terminology, and connect business concepts to database structures. Essentially, a conceptual or logical ERD will visually show how business concepts relate to one another. They are especially helpful in clarifying information models for relational databases and helping business users understand database structures at a high level and without all the nitty-gritty details. One of the most common and powerful uses of an ERD is to reconcile scenarios where the database design does not necessarily reflect the business domain. And this model is also useful in helping you come up to speed on a new business domain and clarify unclear language or industry-specific terminology. Next, let's talk about a data dictionary. This provides detailed information about the business data, such as standard definitions of data elements and their meanings and allowable values. While a conceptual or logical entity relationship diagram is going to focus on those high-level business concepts, a data dictionary will provide more detail about each attribute of a business concept or each field that might get stored in a database. Essentially, a data dictionary provides a tool that enables you to communicate business stakeholder requirements in such a way that your technical team can more easily design a database or a data structure to meet those requirements. If you've been wondering what to do with those crazy, ridiculously long lists of fields that end up inside your use cases or user stories or other requirements documents, you'll be happy to learn that they have their ideal home in a data dictionary. So use the data dictionary to specify those details, to update an existing database or create a new one. And creating a data dictionary is for all impacted data repositories is an essential first step to creating a data map, which is what you need for a system migration or integration project. And we're going to look at those after we discuss a higher level diagram for modeling data flow. So let's talk about that next. A system So next, let's talk about system context diagrams. And in today's information-rich world, it's very common to have multiple systems sharing data or passing data back and forth. And often on a project, we'll focus on updating one system, but these integration points or ways that data is passed back and forth between the systems also need to be considered. If the way data is stored and managed in one system is changed, then those integrations with another system could also be impacted. And a system context diagram shows how one system interfaces with those other systems. It visualizes how the primary system, the one that's at the center of your project, exists, quote unquote, in context with the other systems. Use this model anytime the scope of a system and its interactions with other systems is unclear. It is a useful precursor to a detailed data map, which shows exactly what data flows in between those two systems, and we're going to talk about that next. It's also useful during the scoping phase of a project to understand the potential systems that might be impacted by your proposed solution. And so much so that even though I keep my scope statements really simple, as short as 3 to 5 pages, I often include a system context diagram inside that short document. Okay, next, let's talk about data maps, which are a special type of data dictionary or requirements analysis tool, showing how data from one information system maps to data from another information system. In a data map, you analyze the detail, field by field, of how data from one system gets added to another system. And as part of doing this analysis work, you will also want to discover any potential mapping issues, which there are typically quite a few. Some examples could include, the field length of the source database may be longer than the field length of the target database, and that would lead to truncated data if you don't decide what to do with it. Another potential mapping issue is that the lists of available values or lookup fields are different between the two databases. And then you need to handle this with a translation rule or some sort of a lookup. It may even be possible that a single field in one database needs to be split into 2 or more fields before loading it into another. Or the reverse, that a single field might need to be created out of 2 separate source fields. Data mapping specifications are useful when you're migrating data from one system to another because you need to handle all of those variations. They're also useful when you're integrating data between one or more systems. And they allow us to get really specific about all the rules when it comes to data flow. So before we move on and talk about the scenarios that you use these techniques and how they kind of get sequenced together, let's talk about 2 really, really common questions that come up. And these are more on the technical side of things. So the first is, can I get by without using SQL? And yes, it is totally possible to learn and apply the concepts in this course without knowing how to do SQL. And I'll let you in on a secret, one that I don't happen to keep very well. I don't know SQL, and I have never written a line of SQL in my life. Yet I've used all of the data models we've discussed to ensure the database design serves the business process and functional requirements for my domain. In fact, I think my lack of SQL knowledge is actually an asset, as it's forced me to ask more questions and engage in collaborative discussions with the database developers and technical architects, rather than just looking at the data myself and making what might prove to be false assumptions. However, to have these discussions, it's really important that you have a basic understanding of how databases are built and organized, and that's why inside the course, we've included a crash course on relational database concepts. The second technical challenge that often comes up around data modeling is around tools. Data dictionaries and data maps are most commonly created in Microsoft Excel or any spreadsheet software. The other models can be created with any visual modeling tool you might have at your disposal. If you haven't used a visual modeling tool before, that's not a problem. Pen and paper also work, as do whiteboards. What's more, we've included a crash course on visual modeling tools that you can use, including access to free trials and affordable web-based options. And with each of the visual modeling lessons, I'll demonstrate how to create the model in Microsoft Visio, since that's one of the more common tools we see organizations using. You'll receive sample Visio files for each model that you can use right away in your business analyst work. So now let's talk about different project scenarios for data modeling, because we've discussed why it's important from a business perspective and taken a high look at the techniques that you use to model data. Let's look at how it fits into a few different types of project scenarios in business analysis life cycles. So the first is a system integration project. System integration projects involve migrating functionality supported by one system to a new system. In today's technology climate, often organizations are migrating legacy technology systems, such as those that are proprietary and custom to a single business, to commercial off-the-shelf systems in the cloud or the software as a service SaaS solutions that are supported by third-party vendors. For example, an organization could replace their homegrown lead management or customer management system with Salesforce.com or SAP. Another scenario is when an organization is moving from one third-party system to another. For example, while I was creating this course, I was evaluating changing shopping cart systems. During systems migrations, there are many steps in the business analysis process. You start by analyzing the scope of the project and creating a business case for changing systems. The scope may include a list of key business processes and high-level features that need to be supported. And a system context diagram can be useful here to show how the current systems support the business process or how data flows between those systems. At this point in the project, you might create a high-level conceptual data model like a glossary of key terms and an entity relationship diagram to show the relationships between critical business concepts, as you want to make sure that any tool you evaluate can manage the right types of information and the right relationships. Then you may evaluate multiple vendors or third-party tools, perhaps using a request for proposal process to receive comparable bids. And once you select a vendor, you begin working on requirements specific to transitioning your current system to the new system. Business processes get more specific. Functional requirements analysis looks at any type of customizations or configurations that are needed. And from a data modeling perspective, you'll most likely complete a data map that details how data from your original system will get loaded to the new system. Of course, the actual loading of the data is a technical process, right? This is not what we do as BAs, but there are a lot of important business decisions to be made before we execute on that process. Questions like, do we bring over all data or recent data? For any two fields, do they actually mean the same thing, or is there logic in either system that will impact how we want the data brought over based on our understanding of the business process and functional flow? Again, things a developer is not necessarily going to know. Do all of these fields have a home in the target database and vice versa, and so on and so on? Also, simply letting the technical person know how the key concepts link together will help them be much more efficient and accurate in their conversion process. especially if they're unfamiliar with your business or business domain, which is common when you're hiring somebody who's an expert in the new tool. They're not necessarily going to know your business. And this might sound like a lot to consider, and that's because it is. Rest assured that by the time you get through the lesson on data maps, you'll have a structured process to go through that will help you discover and resolve any potential issues. Another type of project where data modeling is of critical importance is a systems integration project. And unlike a system migration project where one system is being replaced by a new system, a system integration project results in two or more systems working together on an ongoing basis to support a business process. For example, the Bridging the Gap shopping cart system that you use to purchase this course integrates with both PayPal and a third-party credit card processing system for accepting payments. It also integrates with our virtual course delivery system to ensure that new course participants are automatically set up with access to their course content. And behind each of these integrations is, you guessed it, data. On a project like this, your business analysis process might flow like this. You might start by creating a system context diagram to clarify how the different systems pass data back and forth. Then you might evaluate your current business processes and any manual steps that result from lack of system integration. For each system that is part of that overall solution, your source systems and your target systems, you'd probably create a data dictionary to specify the type of information contained in each data source. Then, as you look at each specific business process and how the systems integrate together, you will complete a data map to show the specific fields passed between each system and the business rules for mapping data from one system to another. System integrations and migrations are two more complex types of projects in which data modeling techniques are absolutely essential. However, even on what might be considered a simpler project, you can benefit from using some of these techniques as well. So let's look at an example from a new or updated software feature. Now, a very common BA scenario is to spec out a new software feature, whether for a customer-facing project or for an internally used system. So let's pick a very simple example this time, one that specifically does not involve any integration with other systems. Although system integrations are so common that when I was preparing this lesson, I had to sit for a few minutes and really think hard about a realistic but simple example. I did find one, however, so let's talk through it. When I go to my local chiropractor, I check in using a software system. I provide a unique identifier, and then I proceed to list any areas of pain that I'd like the chiropractor to address during my appointment. The system shows me a picture of the human body divided into different zones, and I select the part that is bothering me and answer a series of questions about the pain, such as how frequently it occurs, how severe it is, and what treatments make it better or worse. For the sake of an example, let's say I am the business analyst working for the product development team that builds and updates this chiropractic check-in system. Our chiropractors have been letting us know that patients would really like to be able to multiple select zones, especially when zones are near each other or overlapping. As a product development team, we decide to allow patients to multi-select specific sets of contacting zones, but not select zones all over the body, because it doesn't seem to make sense to provide information about your neck pain and your foot pain together, for example. But it does make sense to select the 3 different parts of your lower back or your hip and your tailbone. So when specifying how the new multi-select feature would work, we'd need to make some very specific data-related decisions. The zones are already defined in our existing data model, but now we need to identify what zones could be selected together and how the information is collected when multiple zones are selected together. On a project like this, your business analysis might flow like as follows. You might first create a conceptual data model captured as an entity relationship diagram to show how the new concept of a multi-select zone relates to your existing concepts. Then you'd add a new term to your glossary for multi-select zones. And then you'd evaluate your data dictionary and indicate the allowable values for when multiple zones are selected at once. And since this is a project only impacting a single system, the other models of data mapping and system context diagram are probably not necessary. Okay, so now that we've seen how data modeling applies even on smaller projects, let's turn our attention to the mega of data projects, the data warehousing or business intelligence project. And these projects are specialized versions of system integration projects. Most often, a business intelligence project involves creating a centralized data store of all information that a business manages for the purposes of enabling intelligence-driving reporting or better business decisions. Organizations use one of the many third-party tools to create this data warehouse, manage the relationships between all of the data, and enable business users or technical report writers to create and automate a wide variety of reports. The data modeling aspect of your business analysis process might flow as follows. You might start with an entity relationship diagram that describes those high-level business concepts that are critical to your business intelligence effort, and a glossary to define key business terms. This is especially important as you add multiple source systems, because each of those source systems might actually use different terminology to talk about what is essentially the same data, and your data warehouse needs to reconcile all of that. Then you might create a system context diagram to model the flow to and from the source systems and the data warehouse. Then you would likely need a data dictionary for each data source that's going to be added to the data warehouse and for the data warehouse itself. And then finally, you're going to need to individually map each data source to the data dictionary for the new data store that is going to be part of your business intelligence system, and you're going to use a data map to do that. In addition to understanding the data modeling techniques covered in this course, you'll need to be an expert or quickly be able to become an expert on the business intelligence tool that the organization has selected. And you also need to understand more about data warehousing, physical database models, and best practices for those kinds of projects specifically. Now, for sure, the data modeling techniques we have been talking about are most frequently used on software projects. However, they can also be relevant in situations where you aren't actually touching the software at all. On one project, all of the inputs to the business process were provided using paper-based forms. And getting a handle on the data provided via those forms was critical for me to understand the business domain. Using data modeling techniques actually helped me get up to speed pretty quickly in what was a really extremely unfamiliar business domain. A data dictionary, I used it to identify the key fields across all the forms and get a consolidated view of how all these forms related together. I created a system context diagram to map out the key places data was input from the forms and how those systems connected together. And as we merged the forms with some updates to those systems that were managing the data, I did create an entity relationship diagram to step back and look at the big picture of what concepts needed to be managed and how we could implement the business process inside the constraints of the current system and how it managed data. So data modeling really is relevant anytime you're looking at how an organization manages data. Often that's going to touch software systems, but not always. It's still relevant even with paper-based forms and manual processes. So another question that tends to come up is, how does a set of techniques like data modeling fit into an agile software development process? Now, by its nature, agile software processes break the requirements design, implementation, and testing up into smaller pieces to be delivered incrementally, often by user stories prioritized in a product backlog. A common mistake would be to create one user story for the data. And unfortunately, it's just not quite that simple. Instead, what we see most commonly is that the data models that you create, that we've talked about in this lesson, often span multiple user stories. And so they're like background information that get attached to the user stories that you are going to consider in a sprint and epic, or that are part of your product backlog. So when you create data models as part of your business analysis work in Agile, it's going to give you that big picture view. And then you take those details and put specific data requirements like adding or updating a new field or mapping one field to another into a specific user stories. Now, when you read through the above scenarios, one thing you'll notice is that it's not always necessary to use each technique on every project. In the course, you'll get to learn how to use each technique and actually create a practice model so that you get to experience and get feedback on that technique. Inside a specific project, you can be more selective about what techniques to use when. It's also not uncommon for more experienced analysts to fuse multiple models together into a view that clearly represents the critical information related to the requirements and challenges that are surfaced by a specific project. So rather than worrying about this being a checklist of new techniques you must use, think of this course as a way of expanding your toolbox so that you are better prepared for an expanded set of projects and qualify yourself for more business analyst jobs. Now, we've talked about what data modeling is, discussed why we do it as a business analyst, and reviewed the data modeling techniques that we'll be covering in depth in the course. And we looked at how those techniques fit together in different project scenarios. Remember, this is the how to get started lesson. It's the 30,000-foot view of data modeling so that we can all get on the same page as to what's covered in the course. In the next set of lessons, you'll be learning how to use each of the techniques to clarify your business and data requirements. Along with each of those lessons, you'll receive work samples and templates so you can see what these data models actually look like. One important aspect of the course is that you apply what you are learning on a real-world project or domain. Now, you don't have to be in a formal business analyst role to do this, and you don't even have to have a project team to share your work with. But you do want to pull from a domain that you are familiar with and that has a certain degree of complexity, which will allow you to experiment with each of the models. So consider any system you use today or any aspect of your current work where you're managing information. What information is managed? What information gets passed between different systems or processes? And inside the course, we'll be building out a case study for a job board domain. And the key concepts of a job board include things like job postings, employers, recruiters, applicants, and applications. So similarly, the domain you choose should have at least 5 big picture concepts that you can work from. A typical job board also integrates with other systems, for example, other job boards and applicant tracking systems. Similarly, you want to be sure there are at least 2 different systems managing information related to the domain you choose. This will enable you to create the models that show the flow of data between systems, like the system context diagram and the data map. So consider the domain you will choose, and when in doubt, choose one you are working in now, whether that be in your employment, through nonprofit work, or in your personal life. Even if you are not yet a practicing business analyst, you'll often receive immense benefits from tackling a work-related collection of terminology. Oftentimes, I've seen a course participant begin an analysis exercise and assume that they would only benefit and that they're just kind of practicing it just to make Laura happy as part of the course, right? And then in a short amount of time, they see their work spread. And as a result, they find even more opportunities to do business analysis work without yet being in a formal business analyst job role. It's beautiful. It's magic. I love it. And the same applies for aspiring or out-of-work business analysts who are able to contribute to a nonprofit organization or a small business in a volunteer or pro bono capacity. However, if you are not currently working or volunteering, it's totally okay to consider a personal domain or expanding on the job search related set of terms included in the work sample, or even looking historically at something you've done in the past in your work. And if you are going for a certificate of completion, this is a good time to download your course workbook and answer the first prompt. Describe the domain of choice and any project related to the domain in your course workbook. And then you're ready to get started reviewing the course lessons on the individual data modeling techniques, the first one of which is already available inside the course platform. Thanks for being part of Data Modeling for Business Analysts. I look forward to helping you take these forward steps in your business analysis career. And until next time, this is Laura Brandenburg of Bridging the Gap.